So the next part of optimization that we'll discuss are basically story problems. And like with any story problem from high school, the first problem to deal with is to take information that is presented in a story or as a paragraph and to distill out what the mathematical structure is that we need to understand. So we'll look at here sort of a classic example of these kinds of problems. So I'll just write out what one of these might look like. Suppose you have 100 meters of fence and you wish to enclose a garden along the side of, say, a barn. Um, how how should you build to maximize the enclosed area? So probably the first step on any of these is to just sketch a picture of what's going on. So I'm not an art major, but we'll give it a whirl. So let's suppose that this is the edge of our barn, and we want to enclose, well, probably want to make some sort of rectangular field. I probably should have said that in the problem, that in this case we'll assume it's a rectangle. And so we want to have our garden inside here. So we need to distill out from this statement basically where's the math problem here. And the first step to do that would be, well, if I need to specify how to build a garden, then I need to tell whoever's going to build it, or myself, what are the dimensions of this garden? How long is the segment that's parallel to the barn wall? How much is what are the segments that are perpendicular to the barn wall? So since I don't know what those are going to be, let me just give them some variables. So for example, let's put x being the perpendicular sides and y being the parallel side, or whatever, just pick something. And then we need to distill out, well, what do we have to work with here? So we have, in this case, 100 meters of fence. Now, what does 100 have to do with the total amount of fence that I would be using? So if these are my dimensions, then the fence used, or the amount of fence, would be 2x plus y. And hopefully it's pretty clear that it would be silly to not use all 100 meters that you have available to it. And so our constraint is that, well, we should probably use all 100 meters of fencing. So the 100 on the right is the number that was available to us, and 2x plus y is sort of the geometric quantity of what the fence would be when we constructed this. Now, that's only one part of this, though, because we wanted to maximize the area. So the thing that we want to maximize is called our objective function. Okay, and in this case, the statement even just said what function we want to maximize. Well, we want to maximize area. There's just one problem, though, or at least for now. The area of this rectangular field is going to depend on both x and y. So for right now, the best that we can do is to say that our objective function is a of x equals xy, because if I have a field with that's x along one side and y along the other, then the area is just the product of the two dimensions. And in this case, this is xy. So the first step in doing basically any of these problems is to distill out the constraint or constraints, sometimes there's more than one, and the objective function. What are we trying to maximize or minimize? and what limitations do we have on the variables that are associated with it. Now, in class, we'll talk about how to actually solve the problem from here, but this is at least a good setup to start thinking about what are you trying to optimize and what are the constraints for doing so.